The first step of gear design starts with designing the gears according to the required specifications. This includes determining the number of teeth, pitch diameter, module, pressure angle, and other key parameters. The design also needs to consider factors such as the load, bearing capacity, rotational speed, and the mating gears with which it will interact. Advanced CAD computer-aided design software is often used to create accurate 3D models of the gear. These models can then be used to analyze the gear's performance and make any necessary adjustments before the manufacturing process begins. Mold design and fabrication. Based on the gear design, a mold for injection molding is designed. The mold must have cavities that precisely match the shape of the gear. It typically consists of two main parts, the core and the cavity. The core forms the internal features of the gear, such as the holes and the root of the teeth, while the cavity forms the external shape of the gear, including the tips of the teeth and the outer diameter. The mold is usually made of high-quality steel to withstand the high pressures and temperatures involved in the injection molding process. Precision machining techniques such as CNC, computer numerical control, milling, and EDM, electrical discharge machining, are used to fabricate the mold to ensure the accuracy of the gear's shape and dimensions. Venting systems are also incorporated into the mold to allow air to escape during the injection process. This is crucial because trapped air can cause defects such as voids or incomplete filling of the gear cavity. Material selection. The choice of plastic material depends on various factors such as the required strength, wear resistance, and operating temperature of the gear. Commonly used materials for plastic gears include acetyl POM, nylon PA, and polycarbonate PC. Acetal is known for its excellent mechanical properties, low friction, and good wear resistance, making it suitable for gears that require high precision and smooth operation. Nylon offers good toughness and resistance to chemicals, and it can be reinforced with fibers to enhance its strength. Polycarbonate has high impact resistance and transparency, which can be useful in certain applications where visibility or shock resistance is important. Injection molding process. Processing the material. The plastic material is usually supplied in the form of pellets. These pellets are first dried to remove any moisture, as moisture can cause problems such as surface defects, reduced mechanical properties, and degradation of the material during the injection molding process. The dried pellets are fed into the injection molding machine's hopper. Inside the machine, the material is heated and melted through a heating barrel. The molten plastic is then injected under high pressure through a nozzle into the mold cavity. The injection pressure, speed, and temperature are carefully controlled to ensure that the plastic fills the gear-shaped cavity completely and uniformly. Cooling and solidification. Once the cavity is filled, the plastic is allowed to cool and solidify inside the mold. The cooling time is an important factor that affects the quality of the gear. If the cooling time is too short, the gear may warp or have internal stresses due to incomplete solidification. On the other hand, if the cooling time is too long, it can increase the production cycle time and reduce productivity. After the gear has solidified, the mold is opened and the gear is ejected from the mold using ejector pins or other ejection mechanisms. The ejected gear is then ready for further processing such as deburring, inspection, and quality control. Processing and quality control. Deburring. The gears may have small burrs or flash left over from the injection molding process. These are removed through deburring operations such as tumbling, grinding, or using precision cutting tools. Inspection. A comprehensive inspection process is carried out to ensure the quality of the gears. This includes visual inspection for any surface defects such as cracks, pits, or incomplete filling. Dimensional measurements are also taken using precision measuring tools such as calipers, micrometers, and coordinate measuring machines, CMMS, to verify that the gears meet the design specifications. Testing. Functional testing of the gears may involve checking their rotational characteristics, load, bearing capacity, and meshing performance with other gears. This can be done using specialized gear. testing equipment to ensure that the gears operate smoothly and meet the performance requirements of the intended application.